Question 11, we are talking about what happens when there's damping, increase in damping in a forced oscillation. You may be interested to see, right, that the wording here, right, is actually an increase in damping rather than, right, the effect of a presence of damping. Because, right, the usual graph that we see, which is what I've drawn here, this graph, right, already has damping. Uh, and but the damping is very light. It's just, right, like you have a forced oscillation of a pendulum in air, so you have some air resistance, so it's very light. We wouldn't draw in exam, right, the graph of forced oscillation with no damping at all, because, right, such a scenario is hard to find in real life. So the default graph, right, that you start off with is already the light damping graph. Then, right, you go on to the increase in damping. So with that, right, the new graph will have two features. Number one, right, you see, with the increase in damping, right, at any frequency, you will expect, right, that the new graph is like lower than the original graph. And that must be common sense, right? Because with more damping, right, the oscillator definitely cannot have as much as great an amplitude, okay, or you struggle to have such an amplitude. And number two, right, is resonant frequency will drop. Okay, so the new graph, right, will be lower than the original graph, and the peak will shift to the left. Okay, so this left hand side here, right, there mustn't be any intersection. Okay, so this graph, right, mustn't intersect. Okay, must not intersect at all. So with that, right, for this question, the answer will be just A. I mean, A is so easy to figure out. Okay, yeah, and the rest of the options, right, are also easy to tell why they are wrong.